One of the things that always bugs me when I'm working in academia is when a class presents a material and they don't tell you why you're learning it, right? Like the whole purpose is just lost somewhere. It's really hard to be motivated if you don't know why you're studying what you're studying. And for me, a prime example of that was cyclohexane. In organic chemistry, when we got to chapter 4, suddenly the textbook was obsessed with this one molecule, cyclohexane, 6 carbons in a ring with 2 hydrogens on each carbon. And all the different ways you could like flex and twist and so forth. And I'm like, okay, that's kind of interesting, but like, why are we studying this? Why is this so important? And the reason turns out to be that this is a simplified version of this. This is glucose, the chemical that keeps your brain alive. This is one of the most important molecules in organic chemistry. And it essentially starts with a cyclohexane ring and makes a few modifications, mostly adding oxygens all over the place. So by understanding the different ways that cyclohexane can flex around, you're getting some beginner steps in understanding how this thing can flip around. Because this is more complicated, right? This molecule can actually break at the oxygen and straighten out into a 6-member chain, and it can curl back together the other way. It can make alpha glucose or beta glucose. So there's a lot more elaboration that can be done. But the reason I think that they study cyclohexane so much is to get you used to the idea of 6-membered rings, which not just glucose, but many molecules have.